Hello, welcome to lesson 3 in the derivative series. We are now going to look at the product rule. The product rule is a rule that when two functions are multiplied together, I can take the derivative of that product of functions and we will explore how. So, we know that the power rule exists, that when I have a function that is made up of monomial terms written together in some long or short polynomial, that I can deal with the coefficient and the exponent of each term to find the derivative of each term, and then the sum or difference of those terms. Derivatives equals the derivative of that sum and difference of terms. The same thing can be said about the product, because again, limits and derivatives are in a sense the same thing, because a derivative is a limit of something. So the product rule, or the properties for products of limits apply. The limit of a product equals the product of the limits, which means I could multiply those polynomials together before I do the derivative and then do it, or I could do the derivative with those as a product and the answers should be equivalent. So we're going to find out that that works or does not work and then look at the rule if it does. So let's take a product of two functions. The functions f and g. That's a product, okay? I can put a dot there. If this board was better calibrated, I could put a dot there. So, there we go. I could put a dot there, but that's not the same thing as this. Okay? This is a composite function. Board's going crazy on me. This is a composite function. This is a product of two functions. Okay? So this is not what we're talking about right now. That will be later. This is what we're talking about. What you find is I can write this in mathematical ease writing as the following rule. The derivative of the first, that's the prime, all right, times the second plus the derivative of the second times the first. That is the product rule. The product rule is if I have this and that, and I want to take its derivative, the derivative of that, I can do it as the derivative of the first, which I could have written dy dx or df dx, right? So there's a lot of ways I could do it. F prime is the derivative of it. So the derivative of the first times the second plus the derivative of the second times the first. That's really what it is, in words. The derivative of the first times the second plus the derivative of the second times the first. So I could take the derivative statement here, and I write it a little differently. I write it as derivative of the first times the second plus derivative of the second times the first. Okay, the board's still not really great. But when I write it this way, it's a quick and easy way for me to understand it. Okay? So I'm going to use this instead of that because that just looks easier. It's easier to look at. It's easier to understand. There's no real messy way to not see it. Okay? So here we go. I'm going to write that up here. Derivative of the first times the second plus derivative of the second times the first. Okay? So, let's put a function up here. What if I want to take the derivative dy dx of the following? 2x squared minus 3x times 4x cubed plus 2x squared. Now, so properties of limits say the limit of the product is equal to the product of the limits, right? So it's saying that I could either do the product first and then take the limit, which in this case is the derivative, or I could do the individual derivatives first and then do the product secondly, and I should have an equivalent statement. Let's see if that's true. I'm going to do the derivative rule as is first, because that's generally how you're going to do it. All right? But sometimes you'll choose differently. So the derivative of the first, this is the first, and this is the second. Okay? So the derivative of the first is 4x to the 1 minus 1 times 3, 3x to the 0. That's the derivative of the first. Yes? Times the second as is. I'm going to write the second. 4x cubed plus 2x squared. Okay? Then plus, I'm going to put the plus in red because that's the formula, right? The derivative of the second, which is this one. So 3 times 4 is 12. X to the 3 minus 2. 3 minus 1 is 2. Plus 2 times 2 is 4. X to the 2 minus 1 is x. Right? Times the first. So I'm going to have to move all this over a little bit. Oops. Let's do that. Oh, come on, board. You're killing me here. All right. All right. Let's move that over a little bit. So I've got room to put the first in on the back, and the first goes over here, 2x squared minus 3x. That's the answer, okay? And on the first set of work, the first set of homeworks, right, I'm going to want that kind of answer. I'm going to want that answer to be what you give me, so that I have the ability to look and say, did they do derivative of the first times the second plus derivative of the second times the first? Now, the back of the book, they may or may not do that, but eventually they're going to simplify it out. And I could leave it that way. I could simplify it this and that. I could simplify it all down to one common, polynomial statement. So there's a lot of ways I can show the answer, but this is what I want to see. If you simplify it down, I would practice that, get good at it, okay? But do a bunch of them and simplify maybe 10 of them. Simplify the 10 hardest ones. Don't simplify the 10 easiest ones and not challenge yourself. Make sure you can simplify down and get those ones so the answers appear as they do in the back of the book. Figure out what they did based on their answers. If you simplify it step by step, you can find their answer, and usually it's doable. So don't cheat yourself. I'm not saying you got to do it for all of them. Because you're doing homework to be practicing, not to be busy. But once you've got it, and you're pretty sure you've got it, do some simplifications and make sure you can do that too, because that's a critical piece of that AP test. So this is the answer, but let's simplify it down because I want to get it as simple as possible so I can compare it to the other one, because I'm going to bring them both down to their simplest forms and check equivalency. That's the simplest way to check equivalency. Simplify both statements you think are equivalent and see if they match up. And if they match up, when I try to move everything to the left and right to combine them, I will get 0 equals 0. I'll get an identity. Okay? But when I've got 2x plus 5 equals 2x plus 5, you know that's an identity statement. That means those are equivalent statements. So if I do this, I'm going to have to do this with FOIL. 4x times 4x cubed is going to be, 16x to the 4th, right? So that's this one. And then this one is going to be 8x cubed. Then this one is going to be negative 12x cubed. And this one's going to be negative 6x squared. Yes? So far, so good? And I can continue on, which I think is good, but I notice right there, let's go ahead and do that. That makes life easier. 8 minus 12 is negative 4x cubed. Gives me just a little bit more space because sometimes I need it. What you're going to find is the answers are often longer than the questions sometimes in calculus, which is very, very disconcerting to people at first, but really in reality, that's just the way it is. So let's simplify the other side. Same way, I'm going to simplify the other side with the green. 12x squared times 2x squared, 12 times 2, so that's 24x to the 4th, right? This board is killing me. I need to be in my old room. This is Mrs. Dr. Taylor's board, and it is not working properly. 12 times negative 3 is negative 36, right? 24x to the 4th. The farther I go to the right, the worse this board is, so it's very hard to tell. X squared times x is x cubed, right? Then positive 4 times 2 is plus 8x cubed. And positive 4 minus 3 is minus 12x to the x times x is x squared. And again, we see that we have x cubes in common. So I'm going to come back over here. I'm having a hard time with this. So it's 24x to the 4th minus 36 and a positive 8. So 8 from 36 is basically what we're doing. What do you get as an answer? You can do the algorithm, or you can think about, well, if I move this up to, that would be 20, then if I take my 2 back off, what would it be? Or that would be 30, I should say, then I take my 2 back off, it would be what? Right, 28, okay. So mental math tricks of grouping, adding, and subtracting, so you don't have to grab your machine all the time. And if you don't know if that's true, you count up. 28, 29, 30, 31, 32, 33, 34, 35, 36. That's 8 fingers, that's 36, okay? So those elementary school tricks still work. You do them mentally now. You don't need that stupid machine all the time. These were x cubes, right? And then minus 12x squared, okay? And now, finally, we can put stuff together. I've got x to the 4ths and x to the 4ths. I've got x to the 3rds. Notice I grab its sign. And x to the 3rds. I would have grabbed its sign, but the board messed with me. And I have x to the squares and x to the squares. And so if I want to extend this page for just a second so you can see it, 16 and 24 is 6 and 4 is 10. 30, so that's 40 x to the 4th. Negative 4 and negative 28 is negative 32 x to the 3rd, right? And negative 6 and negative 12 is negative 18x squared. So that's the simplified form. Okay? That's the simplified form. Now, I'm going to go ahead and try to do the other side. And what I'm going to do is, real quickly, I'm going to come out of whole screen and clone this, so that I can use that same writing and just erase this stuff out of here. Okay, get rid of all that. Okay, all right. And I'm going to go ahead and I'm going to extend this page, and I'm going to slide this down a bit so it's out of our way for now, and let's do the work. Now what we're going to do is we're not going to take the derivative first. We just did the derivative of the product. Now we're going to do the product for, I'm sorry, we just did the product of the derivative of the products. We're going to do the product first and then do its derivative and see if that's true. So again, it's just FOIL. 2 times 4 is 8. X squared times x cubed is x to the 5th. 2 times 2 is 4. X squared times x squared is x to the 4th. And now I'm going to distribute the second term into that binomial. Negative 3 times 4 is negative 12. X times x cubed is x to the 4th. Negative 3 times 2 is negative 6. X times x squared is x to the 3rd. And we notice that we get 2x to the 4th statements, yes? So I have 8x to the 5th minus 8x to the fourth minus 6x cubed. All right? I still haven't taken the derivative, but now, I'm going to leave those brackets because that's what they were. Now I'm going to do the product rule. But now it's not a product, is it? Now what is it? Right? When I did that product first, this backsteps me to the power rule. Sometimes the product's so easy to do, it's easier to just do the product and then the power rule. Sometimes the product can be tedious, and it's easier to do the product rule first. Doesn't really matter, but now I can apply the power rule to check my derivative. 5 times 8 is 40. X to the 5 minus 1 is 40x to the 4. Negative 8 times 4 is negative, what's that? 8 times 4, 32. X to the 4 minus 1 is 3. And then negative 6 times 3 is negative 18. X to the 3 minus 1 is 2. And I extend my page. And lo and behold, we see that they are indeed equivalent statements, aren't they? So we have just verified in one specific case that it doesn't matter which way I do it. The product rule works, and I could do the product first and the power rule to verify that. We could do it over and over, or better yet, we could do it in general, but that would just bore you to tears or confuse you. But if you play with it and you can write it in general form for me, I'd be willing to give you some bonus points, or I bet your instructor would, because it would be valuable and it would be a deeper thinking exercise worth something, at least bonus bank. So let's look at another product. Let's do the derivative of 3x plus 2 times 5x to the fourth minus 3x squared plus x minus 5. Okay? Now, if I did the product, I'd have basically 1, 2, 3, 4 terms times 2. What's 4 times 2? That's 8. I'd have 8 terms that may or may not combine, and then I'd have to do that. And in getting those 8 terms, you know, I would have to do all that distribution. And as this gets bigger and bigger, that gets more and more tedious. Easier just to do the derivative rule for the power rather than the, for the product rather than the power rule. So let's do the product rule, which is derivative of the first times the second plus derivative of the second times the first. Okay? So let's go ahead and apply that. The derivative of the first is 3x, right, to the 1. So 1 times 3 is 3. X to the 1 minus 1 is x to the 0. Huh. And what's the derivative of any constant? 0. So there's the derivative of the first. This is derivative of the first. Not bad, right? Times the second. Don't do the derivative of the second. That's where many people mess up. It just gets rewritten. Times the second. I'm using the same color ink to show what I've done a derivative and what I haven't. Now plus, because that's the rule. The rule is plus. Now the derivative of the second. Well, now we're saying, okay, 5 times 4 is 20. X to the 4 minus 1. I'm going to come over here. 3 times negative 2 is negative 6. X to the 2 minus 1 is x to the 1. Plus x to the 1. 1 times, how many ones? That's one of them. 1 times 1 is 1. X to the 0, which I don't see. And this, it becomes a 0 the same way that did when I took its derivative. Yes? So that's the derivative of the second. Don't forget times the first. 3x plus 2. Okay? Now I could distribute that out, blah, blah, blah. I'm not going to. Okay? I'm just not going to do it. Though I could. It would be tedious. But we can see. It's 3 times that second plus this times that first. So this is the derivative of the second. and that's the first. So you can see there's the algorithm, derivative of 1 times 2 plus derivative of 2 times 1. And I'll label my stuff for a while. I would if I were you. By doing so, what you've done is you have made an outline of your logic. And you can simplify from there. All right? Let's look at another one. First of all, is that a product? Yes. Did I do its derivative? Yes. What's going to give me trouble, though? Those rational expressions with the x on bottom, yes? So what makes sense is I would probably want to pop those bad boys up to do the derivative, bring them back down in my answer to finalize it. Okay? So let's do a rewrite. This is okay. This becomes 1 x to the negative 1 plus 1 x to the negative 1. This first term is 2. This goes up x to the negative 4. This is good as is, minus 2x to the third. Okay? And so now we can take that derivative. So let's do that. The derivative of the first. This is the first. This is the second, right? So what's the derivative of the first going to be? First term. Very good. 4 times 3. 4 minus 1. And plus negative 1 times that is, oh, what? Ooh, so be careful, right? It's plus a negative. Plus a negative is the opposite of positive, right? So negative 1 times positive is the opposite of positive. 1 times 1 is 1. X to the negative 1 minus 1 is negative 2. Don't forget. Don't goof up. All right? I'm going to move this over a little bit. Just go times the second, which is 2x to the negative fourth minus 2x cubed, right? And then plus, because that's the algorithm. Now let's do the derivative of the second. Now the derivative of the second is negative 4 times 2, which is negative 8. What do you know? All right? But I don't want to change that. This has got multiple terms. Let's just do that. Negative 8x to the negative 4 minus 1 is negative 5, right? And then 3 times negative 2 is negative 6. X to the 3 minus 1 is 2. Okay? And I really should have made that a little closer together. Let me group that so I can squeeze it a little bit. Oh. There we go. And now that was derivative of the second times the first, which is 3x to the fourth plus x to the negative 1. Okay. So is this the final form? No. Can I simplify it further? Yes. What I would do is, it's convenient to leave it this way if you're going to expand it. All right? If you're going to distribute and combine like terms, it's convenient to leave it this way. But again, I said I'm going to leave it derivative of the first times the second plus derivative of the second times the first. So I'm going to write it as 12x cubed minus x to the negative 2. Right? How many x's is there? 1. So that 1's on top, and the x to the negative 2 becomes x squared on bottom. This is, again, negative, what's in front of it? 2. So the 2's on top, x to the positive 4 when I bring it back down, minus 2x to the third plus, okay, negative 8x. Nope, can't do that, right? Because that's a negative there. So negative 5, that's going to flip down, so the negative x is on top, and the x to the fifth is on bottom. This is really frustrating. And the minus 6x squared and the 3x to the fourth and the negative 1 of the x is going to make us flip that. So that is plus 1 over x. Okay? Derivative the first times the second plus derivative the second times the first. All right? See, it looks like the first again. See, it looks like the second again. Okay? All right. That is the product rule. It's pretty straightforward. There's a lot of problems that you can do, and I've given them to you. And I say, go for it, and don't give up.